Good morning, everyone. I am Jinaresh from ECA section studying in IARA College. This is a PPT of AWP subject, and my topic is about antenna measurement facility comparison. Let's get into the topic. Introduction. Antenna measurements constitutes an indispensable part in the development of any wireless system. The increasing complexity and qualification requirement of modern antennas for civil, military, and space applications implies that even the most advanced numerical models and computational tools cannot achieve a complete characterization. Fast and accurate antenna measurements are therefore an important tool for antenna analysis, validation, or calibration. European Measurement Expertise Mapping. The University of California, Calabria, Italy, supported by other WP World Packages partners, has developed a web-based database to map European expertise in antenna measurement. The collection of information in a mean to identify parallel or complementary research activities in the antenna measurement field whose integration and coordination will be of benefit to advance the progress of is. The database provides the scientific and industrial community with a holistic outlook on antenna measurement services. Facility comparison campaigns. Facility comparisons are important instruments to verify measurements accuracies and investigate and evaluate possible improvements in measurement procedures. Most international certifications require regularly scheduled comparisons with other range of reference laboratories as part of certification maintenance. This antenna type have been employed in this activity. The three antenna types are employed in this activity: the DTU ESA, which is 12 GHz frequency validation standard antenna, and the SATIMO, which is 0.8 to 12 GHz of range dual reach horn, which is shortly known as DRH, in the 1.5 to 6 GHz band, and set of calibration standard gain horn SGH covering the 1.5 to 40 GHz range from the DTU ESA spherical near field antenna test facility have been employed. Similarly, comparison campaigns with other antennas have been carried out. DTU ESA 12 GHz validation standard antenna. The VAST 12 antenna was developed by the Technical University of Denmark for the European Space Agency's ESA in 1990s has a specially designed reference antenna. The CFRP form structure ensures thermal and mechanical stability against differences in temperature and gravity orientation, respectively. Between the participating facilities, the offset space, parabolic reflector, and different focal points in the two principal planes, and corrugated circular feed horn provide a pattern with elliptical main beam and spherical challenging characteristics. The operational frequency is 12 GHz for the present campaign. The polarization is linear and the gain is about 30 dB. This figure shows the DTU ESA VAST 12 antenna. Here 12 indicates the range, that is 12 GHz, and Santimo dual ridge, which is in the range of 0.8 to 12 GHz on. Due to the ridge and gridge, horns are much smaller and less bulky than the corresponding standard gain horn at comparable frequencies. Carefully designed dual ridge horn have excellent return loss, cross polar and flat gain response in the 1:15 frequency range. So very few horns are required to cover the operative range of an antenna testing facility. High quality design are based on the numerically controlled precision fitted mechanical part, so very little performance difference can be observed between the similar horns. The Santimo dual range 0.8 to 12 GHz horn, as shown in the figure, is widely used as a broadband reference antenna. The horn is connectorized and essentially an open flared ridge waveguide with lateral base designed at harmonicize gain with the frequency curve. So this figure shows the Satimo dual range horn. At low frequency, the bias appears as a closer surface and increase the broadside gain of the horn, whereas at high frequency the bars are electrically transparent and effective gain decreases. DTU ESA standard gain horns. ACE partners can request the loan for calibrated standard gain horn for DTU ESC spherical near field antenna test facility and compare the measurement broadside gain and reactivity values with reference data from DTU. Measurements on 3 standard gain horns covering the frequency range from 1.55 to 6 GHz, as shown in the figure, have been performed in both the Satimo multiprobe spherical near field systems in Atlanta, USA and Paris, France. Calibrated standard gain horn from the DTU ESA spherical near field antenna test facility. Transverse activities are actions involving other areas of the ACE network. The antenna measurement techniques and facility sharing group is involved in the three major such actions. The action involving the comparison of measurements and numerical modeling has been initiated with the wide band and multi-band antenna activity. The antenna used for this activity is Satimo dual ridge 0.8 to 12 GHz horn. The measurements were performed by Satimo involving 521 frequency points, each of 15 MHz and in the range of 0.8 to 6 GHz bandwidth. The numerical modeling has been performed with the commercial FDTD program from a non-investigate. So both matching peak activity and pattern characteristics have been investigated, and activity involving the definitions and recommendations for the realistic performance evaluation and measurements of smart antennas and multiple input multiple output systems has been initiated with the small terminals and smart antenna systems activities. Conclusion: Facility comparisons are important instruments to verify measurements, accuracies, and investigate and evaluate possible improvements in measurement procedures. Regular inter comparisons between the aggregated measurement facilities are also an important instrument for the measurement traceability and quality maintenance. The activities in ACE provide a valuable possibility to pursue this activity on the large scale. Companies and institutions outside the Europe and non-members of the ACE will subsequently be invited to participate in these activities. The completion of electromagnetic data interface is very important component to facilitate future campaigns and can therefore be seen as critical components for the continuation of this activity in ACE. Thank you.